Guys, we're going to take a look inside of the MFJ Deluxe Versa Tuner 2. I basically, what I planned on doing today is showing you guys how to measure inductance with my LCR bridge. But that ain't going to happen because for some reason, when I turn it on, it just goes right to... there's a problem with the fuse, but it's not a fuse problem. So I pulled it apart, I replaced the fuse, and it's still acting up. So I don't know what happened to the meter. I'm not going to worry about it, but I'm still going to make this video anyway. So inductance is measured in henries, micro henries, and picohenries. So say if this meter was working and I have this air variable coil here, which is an inductor, it's an air variable inductor, I could put it next to tie it into a capacitor and build my own little antenna tuner. Even if I mounted this to a wooden board here, say with these two holes, I mounted it to the board and then I tied it into a capacitor like one of these here, or two of them, because in this particular older model manual antenna tuner, it has a roller inductor. And I made a big mistake many years ago selling some roller inductors that I had at a ham fest, which I'm kind of sorry I did that. But anyway, so inductance, like I said, is measured. So if I was to turn this on and it was working properly in the inductance mode, it would tell me the inductance of this tappable coil as I move these connectors around. Say if I connected this one here at the bottom, and I, everywhere there's a different tap on the coil is going to be measured in different inductance. So say if I put it here, it might, the meter might read like 25 microhenries or picohenries or henries. You know what I'm saying? So I'm still going to run this video anyway, just to give you guys an idea, a gist of how things work. With inductors and capacitors, you can build your own antenna tuner. So this is a just an air wound inductor. That's all this is. You can build these. You can make them yourself. You wind them around a 1-inch, 2-inch diameter of PVC pipe. Just using bare wire, and you can make your own. You could either use epoxy or something like that, and then you can put tappable coils on tappable solder spots, as you can see here. That these wires coming out are soldered onto various parts of the coil. So anyway, with this roller inductor here, if you see inside here, there's a brass wheel. So as I turn this, you're going to see this wheel spin all the way to the end. And I'm going to actually do that. So I'm going to roll this. You're going to see the wheel spin. Now, if I had this LCR bridge working at the moment, which I'll get it working, I have a funny feeling it bypassed the fuse and probably blew a diode out, maybe. Because no matter what I do, even when I hit the two pieces together, it's still reading there's a problem with the fuse. So, but I'll work on that. Anyway, so just tuning this little roller inductor around here to give you guys an example. Like as I'm rolling this thing, obviously it would be showing, different, like I said, readings, and it's got a wide variable range of inductance. So if you got a machine shop or something like that, you can build these things too. If you're good with stuff like that. Roller inductors are a little hard to come by these days. Like I said, I kicked myself in the butt here that I sold a couple of those at a ham fest some years ago, which I'm kind of sorry I did, because I've always been an experimenter and tinkering around with the stuff, but they were a big commercial, high quality roller inductors, and I gave them away for a song and a dance. So, but anyway, so there you go. There's your roller inductors, which is, like I said, it's measured, and here's the inside. A little look of the inside of this MFJ tuner, which basically consists of the roller inductor and two capacitors, to show you, so what you would do is you would tune your roller inductor, until you get like your highest receiving, and you would tune your transmit and antenna capacitor for maximum RF output, which would mean this line here, this needle here would go up, and you want this one to stay down as low as possible. And you got your different things here. You got your dummy load. Now your dummy load is a 50 ohm resistor that they actually put in here, which is right here. This 50 ohm resistor. It's kind of a heavy duty resistor here. It's almost the kind, it is just like the kind they put in, they used to put in their MFJ dummy loads. You got your balance line wire, dummy load balance line, coax 1, coax 2. Then you got your coax 1, coax 2 bypass. And everything on this side here is bypassing the tuner. So it's just using basically the reading of the meter here, but it's bypassing all the electronics and all the circuits inside here. So here you have your output coax 1, coax 2. You plug your transmitter here, and here you have your wire, your balance line, your ground here, and your little power goomazigam to light up the little meter there. And the meter here is converted into DC to make the meter movement. Obviously, that's usually used by diodes to give you your meter movement, because it takes the RF and converts it, or brings it into DC, because these are DC meters. So you got your plus and minus here, and they put a capacitor over it, and there's your little circuit in the back to make everything work smooth. And these things are, they're well built. I happen to have this for a number of years. And I'm sorry I couldn't get to show you guys how to actually measure inductance and capacitance. So you got your, like I said, your roller inductor and your open wound air inductor, which is pretty much similar It's going to do the same thing, you know, except this has that little piece of brass that as you turn the inductor, it changes the inductance. So if I was to take this out and pull the guts out and the center out, and tap, solder tappable wires on just like this, it would function the same way, except I would be using tappable areas of the air wound inductor. So there you have it, a little bit about inductance. Sorry the meter's not working. It's either gonna get fixed or it's gonna be thrown out of the 15th story window. And that's about it. I just wanted to talk a little bit about inductance and how that works and how that's measured and how this stuff actually works in general. Is good to know. These little antenna tuners. So if you look up the word reactance, when you're putting these antenna tuners in line with your antenna, if you're running like say a random length wire or whatever it is, and you're turning these three dials, the inductor and the two capacitors, antenna and transmitter, they have, you want to look up the word reactance. Okay, if you look up the word reactance, you have your inductance and your capacitance. Now, once you start tuning these knobs here, what they do is they cancel out the reactance by adding or taking away capacitance and inductance. And that's what you want to do to have, good RF energy transfer, by canceling out reactance. So you could look all this stuff up online nowadays. I don't have to explain this, but it's just something I felt like sharing with you because, I still have some older equipment left. This isn't that old, but, man, you go back to the days when a person would air wind their own inductor and either build or have their own capacitor, and they would put them on a board. Then they would run the coax through that, and the output of that would be a 100-watt light bulb or something like that. So as you keyed up your transmitter, sometimes you would just tune your capacitor and move the taps around to find the sweet spot. And when that light bulb got its brightest, you kind of knew your transmitter was tuned up and you were getting maximum RF energy out, because efficiency is the key, especially when it comes to antennas. Coax, that's the key factor. You want maximum efficiency on your station when you're transmitting, and antenna's always been the key. Antenna, doesn't matter what kind of transmitter you got, you can make something out of glue and tape, and as long as you got a good antenna, or you're set up, or you kind of got the gist, a little bit of knowledge of capacitance and reactance and inductance, and how inductance and capacitance work together to cancel out reactance, you're on your way to being, better ham radio operator, getting your signal out there and all that good stuff. So, sorry guys, once again, I had a problem with the meter, but you may never see this meter again, or you may see it in the next video where it's actually working.